Have you ever wondered how everyday substances like table salt or baking soda get their identities in chemistry? Why do we write salt as NaCl and not ClNa? Just like sentences are built from grammar, chemical formulas follow strict rules based on atomic symbols and valency. A chemical formula tells us what elements make up a compound and in what ratio. It's chemistry's own language. In this lesson, we'll break down a four-step method to write accurate formulas for chemical compounds, the same method used in labs, industries, and scientific research around the world. The first step is to write the symbols of the ions or radicals involved. Always place the positive ion, also called a cation, on the left-hand side and the negative ion or anion on the right-hand side. For example, sodium and chlorine combine to form sodium chloride. Sodium is a metal and forms a positive ion, written as Na. Chlorine forms a negative ion, written as Cl. So the base format becomes Na on the left, Cl on the right. Similarly, if calcium reacts with sulfate, we write Ca for calcium and SO4 for the sulfate radical. These radicals may contain multiple atoms acting as a single charged group. So remember, positive left, negative right, always. Next, we assign valency to each element or radical. Valency is simply the combining capacity of an atom or group. We place the valency number as a superscript above each symbol. Ignore the plus or minus signs for now, we only use the absolute value. Examples: sodium is Na with valency 1, written as Na superscript 1. Chloride is Cl with valency 1, written as Cl superscript 1. Calcium is Ca with valency 2, written as Ca superscript 2. Sulfate is SO4 with valency 2, written as SO4 superscript 2. Chromium is Cr with valency 3, written as Cr superscript 3. The radical HSO3 has a valency of 1, written as HSO3 superscript 1. These values will be used in the next step to determine how many ions combine to form a neutral compound. Now comes the most important step, interchanging the valency numbers. We take the valency of one ion and write it as a subscript to the opposite ion. Let's start with an example: sodium Na superscript 1 and chloride Cl superscript 1. After interchanging, we get NaCl. Since both valencies are 1, we don't show the subscript. Final formula: NaCl, sodium chloride. Now a second case, calcium Ca superscript 2 and sulfite SO3 superscript 2. After interchanging valencies, both are 2. Simplified to CaSO3, calcium sulfite. Third example, chromium Cr superscript 3 and sulfate SO4 superscript 2. We interchange the valencies. The 3 goes to sulfate, the 2 goes to chromium. Important rule: if a radical's valency is greater than 1 and repeats, always enclose it in brackets. Once the valencies are interchanged, we write the final formula clearly. Examples: sodium chloride NaCl calcium sulfite CaSO3. Chromium sulfate Cr to bracket SO4 close bracket 3. Calcium bisulfite Ca bracket HSO3 close bracket 2. Notice how subscript 1 is never shown. Brackets are used around radicals when they appear more than once. Each final formula represents a neutral compound where total positive charge equals total negative charge. These formulas form the backbone of balanced chemical equations used in industries, experiments, and medicine. Now that we know how to write the formulas, let's look at how compounds are named. First rule: when combining a metal and a nonmetal, the metal is named first and the nonmetal is given the suffix IDE. Example: Potassium plus iodine gives potassium iodide. Formula Ki written as K on the left, I on the right. Second rule, for two nonmetals, use prefixes to indicate the number of atoms, mono for 1, di for 2, tri for 3, tetra for 4. Example, N2O5 is dinitrogen pentoxide. That's nitrogen with a subscript 2 and oxygen with a subscript 5. Third rule, when oxygen is involved with another element, if the compound has more oxygen atoms, it ends with 8. If it has fewer oxygen atoms, it ends with IT. Example, KClO3 is potassium chlorate. KClO2 is potassium chloride. So, formula writing goes hand in hand with correct naming, making chemical language universal and precise. Let's quickly recap what we've learned about writing chemical formulas. 1. Write the symbols positive ion on the left, negative on the right. 2. Assign valencies using superscripts, ignoring signs. 3. Interchange valencies and reduce to the simplest whole number ratio. 4. Use brackets for repeating radicals and omit the subscript 1. Examples we covered: NaCl for sodium chloride, CaSO3 for calcium sulfide. We also learned naming rules, use ID for nonmetals, prefixes for nonmetal combinations, and AT or IT for oxygen containing radicals. This is the very grammar of chemical language, the way chemists across the world write and interpret compounds. In the next video, we'll dive into important formulas, the keys to unlocking how reactions happen. Until then, keep exploring how atoms connect, combine, and create the world around you.